Hi students, today let us learn about another interesting topic, that's electron gain enthalpy. The definition: when an electron is added to a neutral gaseous atom X to convert it into a negative ion, the enthalpy change accompanying the process is called electron gain enthalpy. So it's denoted as delta EGH. So its reaction is like this. X is an isolated atom which is in gaseous state, and when it accepts electron, that is usually electron gets added to the valence orbit, then the atom becomes an ion, that's an anion, and it gains a negative charge, it becomes X minus. So during this process the energy is always gained, okay, and then the values are usually negative. So depending on the element, process of adding an electron to an atom can be either endothermic or exothermic. Okay, they can either release energy, or they can either absorb energy, or they can release energy. So for many element, electron is released when energy is released when an electron is added to the atom, and the electron gain enthalpy is negative. So whenever energy is released, we know that the value is negative, and when energy is absorbed, it is positive. So most of the elements get a negative and electron and enthalpy range, gain enthalpy, because their energies, because the energy is always released, okay, and there is stability in the system. So for example, group 1, 2, 16, 17, all these have negative values, whereas group 0, that is halogens, they usually get the positive value, means their energy is absorbed. So now this is an idea about the group 1, 16, 17, and 0, how their energy gain, electron gain enthalpies are varying. For group 1 it's negative, group 16 also negative, 17 is negative, whereas group 18 it's positive, and because here energy is absorbed. Okay, now why is this the it's like this, we will understand in the upcoming videos, I'm sorry, upcoming slides. The values are positive because electron has to enter the next energy level, means we know that students group 18 is stable because they gain octet configuration. Now when an electron is getting added to the atom, then we know that the electron is entering the next energy level. So when the electron enters the next energy level, then it is quite far away from the nucleus, so as a result the energy is getting absorbed to put that electron in its orbit. Okay, that's why it is getting a positive. Whereas for the group elements like 16 and 17 and 1 and 2, the energy, the electrons are because they've not attained octet, so that is not the case. That's why they're getting the negative enthalpies. Now let's understand the trend across the period and down the group. Across the period, the value is negative because when you look at across the period, electrons are just getting added to the present shell. So electrons get added. So hence the values are negative. Means the atom is small. So the electron doesn't, the energy is not absorbed here, whereas the energy will be released because it doesn't take much effort for the electron to get added because the atom is small. Okay, now for the, whereas down the group what's happening students, it is the opposite, because electrons will be added to the next shell. So in that case, electrons are getting added to the next shell, and this is quite a large process because electron has to be added, and when they're adding, the energy is lost. So energy is lost, the values goes on decreasing. Okay, that's why down the group the value of the negative value goes on decreasing, whereas across the period the electron value goes on increasing. You can observe here, except for some analogous series like sulfur and chlorine, if you look at the other, the value is getting decreased. If you observe group 17, 328, 325, 295, 270. Similarly for group 1, minus 73, minus 60, 53, 48, 47, 46. Okay, so the values goes on decreasing down the group. Whereas across the period, you can observe lithium, if you observe, lithium, oxygen, fluorine. Lithium is 60, oxygen 141, fluorine is 328. Okay, so this way the values are increasing. So now we have a problem here. Which of the following will have the most negative electron gain enthalpy and which will have the least negative? Now the options are given: phosphorus, sulfur, chlorine, and fluorine. So these are the four elements for which we should write the most negative electron gain enthalpy and least negative electron gain enthalpy. So if you place these elements in the periodic table, it's very clear that phosphorus, sulfur, and chlorine. Okay, so now as you're going from left to right, we can expect that chlorine will be having the highest electron gain enthalpy. Okay, so that's the right answer. And one more reason would be chlorine is having, if you compare fluorine and chlorine, it would be chlorine again, because fluorine is a small atom and their electron electron repulsion will be more. Okay, and whereas chlorine is a larger element, an atom compared to fluorine, and here electron electron repulsion will be less. So that's why chlorine will be the will have the most negative electron gain enthalpy, and the least negative gain enthalpy will be phosphorus. Okay, because as we go across the period, we know the value goes on increasing. Phosphorus will be having the least negative and chlorine will be the most negative. Okay, so thank you so much, students. Thank you.